Hi, everybody. Welcome to today's webinar. Thank you for joining us. I am Amanda Harmoning. I will be moderating today's event, hanging out in the background and helping answer any questions you have. Also joining me from AERA is Rob Monroe.
Hi, everyone. Rob Monroe here from AERA. I look after membership and technical development. And like Amanda mentioned, we'll both be in the background answering any questions that you may have. Lake has told us that during the presentation, if you got any questions that you want to ask, even while he's presenting, he said, go ahead and fire those in the questions box, which Amanda will show you here in a bit. And we'll get those correct questions addressed for you. And look forward also to a little bit of time at the end. If you have any questions that you want to ask, we'll fire those in the questions box as well. And Amanda will take care of those and we'll get those questions answered for you. So I'll go back to Amanda here real quick and she'll show you how to use that questions box in your toolbar.
Yes, before we hand things over to Lake here, we'll just take care of our housekeeping stuff. There's a couple different ways you can listen in today. If you choose to listen in with your phone, please make sure that you select that telephone radio button and enter your access code and audio pin so that your line is muted. And the other way to listen in is with your computer's mic and speakers. And again, just make sure you have the appropriate button selected, and that will just allow us to make sure there's no background noise during the presentation. And just a couple other quick things. One is that there is a little red box with a white arrow in it. This is your grab tab. This allows you to collapse and expand the control panel so it's out of your way while viewing the presentation. And then at the very bottom, you'll see that there is a questions box. And as Rob mentioned, if at any time during the presentation you have questions for us or comments, just go ahead and type them in there and we will be feeding those questions to Lake throughout the presentation. So at this time, we'll just have everyone just navigate out there quick and find their questions box and go ahead and let us know where you're listening from today. We have members all around the world and we always like to just take a quick minute here and just see who's listening from where today. And it looks like we have somebody listening in Illinois, somebody in South Carolina, Wisconsin, Florida, Arkansas, California, Arizona. You guys are all over the place today. And plenty of responses. Colorado, Nebraska, Canada. Awesome. Thank you, everyone, and thanks again for joining us. And I'm going to hand things back to Rob here quick before we get rolling with Lake's presentation.
Super. Thanks, Amanda. I just wanted to take just a couple minutes to sort of explain who we are. Some of you that are maybe listening in today may not know who AER is or what we do, but we are a nonprofit group and we are a group of engine professionals and we're an association that helps builders and rebuilders, installers, as well as the parts and supply manufacturers, distributors, manufacturers reps, schools. We also have government agencies that are members. We've got over 2,000 members worldwide. Now we've been around for a very long time. We were organized back in July 1st of 1922. And kind of like the bottom of the slide here sort of states, the whole idea of the association, and even like days like today where we're getting together for a webinar, is to just help each other out. Networking is a big part of what we do. You can see that even our ancestors and our forefathers even agreed that when a group of us can get together to learn from each other and to take advantage of these opportunities for professional development, we all learn from it. We are a unique group. Engine building and engine builders themselves are a unique group. So we kind of have to rely on each other to keep our businesses moving forward. Some of the member benefits of being an AERA member, as soon as you get your new member kit, of course, you get your specification manuals. We have 7 manuals out there that you do receive as being a member. We also have a subscription to our Engine Professional magazine. This is a quarterly publication that goes out that has lots of good action-packed articles and application-driven type material that you can take back to the shop and use right away. Even our presenter, Lake Speed Jr. here today, he's written for us in our magazine. So there's lots of good stuff in there. Access to our toll-free tech line, we have that, and that's just a great opportunity to help save you some time and money. We've got our automotive machining online training program. This is a program that's through AERA for engine machinist certification. We've got our Contingency Connection Engine Professional Rewards booklet. That in itself can save you money through vendors and manufacturers. We've got our AERA Corporate Partner Program. So we have things like credit card processing and that sort of thing through our partner program. We've got our Process Pro specification software, and we have 8,600 engines listed within that software with technical bulletins, diagrams, and full range of specs within that software. Last but not least, we've got our online training, our custom training program. This is new for us this year, the custom training program. We have Chuck Lynch, who's one of our tech specialists here at AERA. He is very good at coming to your shop and helping out with custom training. Anything from machine setup to quality control. Chuck can help you maybe with an issue you're having within the shop. Like for an example, you've got some seat concentricity issues or surface finish issues. Chuck can actually come to your shop and help you out with that sort of stuff. Like I mentioned, our AERA Tech Center, this is one of the biggest advantages of being an AERA member. It can help save you money. Reason being is that rather than you spend your time looking up engine information, you can just give us a call, you could fax us, you could email us, tell it what it is you're working on, or just tell us what engine you're working on, and let us do that homework for you. And again, you're better off in your shop making money by strictly just, not having to take all that time to resource these specifications. On the tech line, we've got Dave Hagan, Steve Fox, Chuck Lynch, and myself all work the tech line. That tech line is open from 7 a.m. to 6 p.m. Monday through Friday. You can email us at any time as well. We'll get those calls queued and we'll get you all looked after. Just a quick snapshot before we bring Lake on of AERA membership. It is relatively very inexpensive. 1 to 3 employee shop, which is in the US, is $3.99. If you take advantage of that $75 contingency coupon, it's only $324. So very inexpensive to be a member of AERA. And again, if you think of how much time throughout the year that can save you, it's well worth its money and dues for sure. So we'll get on with the technical program. Our guest presenter today is Lake Speed Jr., and he is a certified lubrication specialist at Driven Racing Oils. He's the son of former NASCAR driver and team owner Lake Speed, as well as former crew member for Bill Elliott. It's a real treat for AERA to welcome our guest speaker today, Lake Speed Jr. Good afternoon, Lake, and welcome, and we appreciate it.
Thanks, Rob. Appreciate it. Hopefully everybody can hear me well, and I appreciate everybody taking the time out of their day to come on and spend some time and talk about testing, which is something I love. Like you said, my background with my dad being a NASCAR driver, I certainly have had a lot of experience and, both highs and lows of good testing and bad testing and good results and bad results. And I know what the difference can make. So looking forward to being able to share that here with everybody today as we kind of go through this whole session. So real quick disclaimer here, because obviously I have the utmost respect for the people who are attending and watching today, that they're the guys who are building engines and running the dynos every day, and I am not trying to tell anybody what to do or claim that I know better, or if I've got secret knowledge. I certainly don't, and so I don't want any of this to come across as condescending or any way at all. I'm just trying to share my experiences and things that I've learned in my career of doing these things, and know where things have kind of led us down the right way and down the wrong way, and I just want to share it. That's all I'm trying to do. I'm not making any judgment on anybody else's thing, and some of this stuff may seem like, well, duh, and I don't want anybody to get the wrong impression or opinion about that by any means. So that's my disclaimer before we get started, that, again, just my experiences, and I'm hoping it's something that's beneficial for everybody. And if you feel like you've already heard it all, then I'm sorry for wasting your time. So with that being said, I want to get into a little bit, like I said, my dad is Lake Speed. If you don't remember For people who don't know about my dad, he was the only American to ever win the World Karting Championship. That's a picture of him up there from 1978 in Le Mans, France, when he beat some guy named Ayrton Senna to become the only American to ever win the World Karting Championship. And then, somewhat ironically, the old Melling spam car down there, Dad worked for Melling for a long time, and obviously we owned our own race team, and I got my start working in the shop, pushing a broom, running errands, dumping out trash cans and all that. And really, after I went to college, I started at Melling, and it was really those Thunderbirds right there is where I got my start. That they were switching from Thunderbirds to Tauruses, and I drew the short straw, which was fine because it was a straw, and I got to work, and I started cutting bodies off cars. And that was the whole part, was get the bodies cut off the cars. And I always loved fluid flow, aerodynamics, and stuff like that. So it rolled straight from there into my experience at Melling, doing aerodynamics and, doing cars and all that. And really, one of the things I was probably really proud of at Melling, we were way behind the Gibbs and the other people in the world in terms of engineering, but we did go to the University of Tennessee and start an engineering co-op with them, where we were bringing in engineers, student engineers at the University of Tennessee, and they would come and spend time at the team and interact with the team and help us, do some of the basic stuff that we needed to do in terms of, engineering work with the race cars, mostly chassis stuff, some aerodynamic stuff. It was the early days for the independent teams of engineering. We found out a few years later that the guy at Hendricks had already had, PhD engineers working for him for 5 years. No wonder we lost to them on a regular basis, and that actually made us kind of proud then when we could actually compete with them every once in a while. Say, hey, we actually outran you guys, and you guys had 10 times more people than we did. And so, good experience, but that's kind of where we're talking about today, where I kind of got that impression from, and kind of cut my teeth, if you will, was, at Melling, building a program from scratch. We didn't have one, and we made a lot of mistakes, trust me. We were far from perfect. As we go on, and I came to work at Gibbs, as Rob mentioned, got really heavily involved in the lubrication side of things, became a member of the Society of Tribologists Lubrication Engineers, went through a training program at Lubrizol, essentially as one of their employees almost, doing training, and then became a certified lubrication specialist. I'm also an oil monitoring analyst. But that's the kind of the neat thing, is that, the time we spent at Gibbs is where a lot of the information that's going to come out today was not only the learning the lessons from Melling, doing things the hard way, but also the seeing what the fruits of that benefit can be applied correctly coming out of the Gibbs side. So that's kind of my background. That's where I'm coming from, and that's why I said, these personal experiences we'll share. And of course, I like race go-karts and stuff, and I like old stuff. 2 strokes, it's a lot of fun. Nothing better than the smell of castor bean oil and methanol in the morning. That's my favorite deal. So let's get on to testing. And these are the kind of the 5 points that I think are really key for any test program. Is one, you gotta have a goal. What are we doing it for? The second is, what's my method? How am I going to go about doing this testing? What are the tools that we're going to use to do this testing? What are the limitations of those tools? Don't assume that the tools you're using don't have a limitation. They all do. So you got to be aware of those limitations. And then, as always, the devil is in the details. There's little things that sometimes we don't know that trip us up, and typically you don't know it until you're too late, you figure it out. So try to share some of those little things that I know from my experience have tripped us up, and then you realize, oh, could have known that. So we'll pass those along. So let's get into it. The goal of testing should not be achieving a desired outcome. Let me say it another way. If you're trying to do a test just to prove a point, you're really not testing. So what happens is, if you have the self-fulfilling prophecy. If you're trying to prove a point, what will typically happen is subconsciously you'll organize the test and run the test in a manner to try to prove something. I know that I've seen it several times in the last probably 8-9 years. I've spent, I don't know how many hours on the dyno. We've spent a lot of that time at Ron Shaver's facility. He has a great facility in California, and we're very fortunate that Ron allows us to go use his dyno cell to do a bunch of testing. And various people will come through and they're like, "Well, what are you trying to prove?" And I'm like, "I'm not here to prove anything." And they kind of look at you like you've got a third eye. And I'm like, "No, we're not here to prove anything. The goal of testing is not to prove a point. The goal of testing is to create reliable, repeatable data that guides decision making. If you run a test, you need to be able to run that test over and over and over again and get to pretty much the same or very close result. As you can see in the dyno graph in the corner down there, from run 185 in September of this year to run 208 in September of this year, that's the variance on the same engine with the same oil and the same conditions. Everything is really, really close. That's good, reliable, repeatable data. When I have a good baseline like that, then if we make a change, a single change, not multiple changes, a single change, and we see the numbers go up or go down from there, then we have data that can guide our decision making. And that's the whole point of testing, is creating data that aids in decision making. As long as that's your goal, then you're approaching it the right way and you can go somewhere. Now, the second part is this. It takes a commitment to that, because that's not a instant overnight success. You end up with some kind of great result. And for example, here, when I was at Melling, one of the things I'm most proud of that we did as a small independent team is when Dodge came back in 2001, we qualified outside front row of the Daytona 500. But that didn't happen by chance. Back in the October of 2000, prior to that, mogged in a terrible season where we were 36th in points, struggling to qualify for races. Everybody in the shop's tired and worn out. Well, the first test for Dodge 2001 was in Talladega in October of 2000. And we didn't have a Dodge built. And we got the team together and said, "Guys, we're 2 weeks out from this test. We have a chassis, but there's no body on it. If we're serious about being a good Dodge team, we've got to get our crap together and build a race car. It doesn't have to be the best race car. We just got to build a race car and go begin the process." So we committed, and all those guys there on that Melling team, we worked days and nights, long hours, and we built the car, got the body put on it, a hole done at Talladega in 2 weeks. And the car went down there and ran, and we learned some things about the car. We took it to the wind tunnel. We learned some things. From that learning process of that car, we then built the car in primer you see there, went down to Daytona again, and tested again, came back to Talladega again. So there was 4 track tests, 2 wind tunnel tests that led up to that car. That single car never qualified worse than 4th in the 5 races it ran and won 2 pole positions. And it was the commitment to the testing back in October of 2000 that led to that performance. We would have never gotten there just as the magic body, the magic spring. It was hard work of just A, B, this body panel, that body panel, this spring, that spring, this truck arm configuration, back and forth, this air cleaner, that air cleaner. The whole package came together over a time, but it took a concentrated effort. We weren't going to get the magic result on the first test. We weren't looking for that. It was a long-term commitment to building knowledge and building data that guided us down the road. And in fact, the crew chiefs and the people from that team that went on to other things ended up winning Daytona 500, winning the pole position, winning lots of plate races, and it was all based on the data that we collected that guided us in our decision making, which helped us become better racers, better at restrictor plate tracks because of that. So I think that's a real that was the first example I thought of when we started talking about testing, and it's a commitment. It takes the right mentality, takes a commitment, long-term thinking to get there. The next thing is the method. So you've got your goal. We're going to collect data, reliable, repeatable data, and we're making a commitment long-term. Well, the next thing is we have to understand the difference between precision and accuracy. I think this is a really great little visual example. You can be very precise, but not be accurate, as you see in the first target. Well, the second target, well, you're pretty accurate, but your precision is not very good. Then sometimes you're just not neither precise nor accurate. Then the ultimate goal is precision and accuracy. And that becomes really important in being able to have confidence in the data you're generating. So always keep this in mind as you go through when you're evaluating your procedure, your test equipment, your test conditions, to make sure, are we being precise and accurate? It's really important to be precise, because even if you're not accurate, but at least you're precise, you can see when you lose precision, and that can guide you back. But of course, the ultimate goal is you want to be precise and accurate. That way, you're moving the ball forward. You're getting to where you want to be in terms of your results in the end. Because in the end of the day, we all do want to get better. We want to do a better job. We want to make more horsepower, go faster, and we need that precise, accurate results that enable us to make good decisions, to be able to move forward. And part of that precision and accuracy comes from planning your work and working your plan. It's really, really important while you are testing to not deviate from the plan. Now, granted, if you blow a water hose on the water break and you got to go do things, well, you got to take care of maintenance of your equipment to keep things going. So don't get me wrong on that. But you need to have a set plan from start to finish that you're going to test, part A, and you're going to test part B, and you're going to test part C, and you're going to test them independently, and you're going to do them at this order and this time, and that you run at the same temperatures and the same pressures, and you keep everything the same. But it's important to have it all planned out. As you see here, we were out at Ben Strader's at EFIU about a month ago, and we did a test, and we had all the oils laid out. We were going to start one of the furthest away. We're going to work one at a time, and we have a different oil filter all laid out. So we're going to do this and this and this. All the parts and pieces are already planned ahead of time. And then you just execute that plan. Then once you executed the plan and you collected the data, only after all the testing is done do you sit back and look at the data. You can make notes about what's happening. You saw something unusual, make a note, but don't deviate. Don't let anything you're seeing influence the course of how you go about running the test. You just need to have a plan, work your plan, stay on target. Then only after it's all said and done, begin to review and interpret the data. Because again, what's the goal? Reliable, repeatable data. We don't want external forces influencing what the outcome may be. So by having a plan and working it helps you stay on track, stay on course to get that kind of data. And part of it, kind of rolls back to the method. The method is not only just having a plan, but also understanding what the limitations of the plan are. One of the things we get to with especially water brake dynos is the noise, right? Like I said here, can you claim a 2 horsepower gain if the dyno varies at least 3 RPMs per run? No, you'll never see it. That's one of the main reasons why, at Gibbs, they went to an AVL dyno, which is $1.5 million, eddy current dyno, was for a Daytona Talladega motor with that plate on it. we were looking for a half horsepower gain. Well, you couldn't do that with a water brake dyno. You know, you didn't have the precision or the accuracy to be able to know that if I gained a half horsepower, was it really a half horsepower gain or not? You couldn't know. So that was one thing that by going to that, it gave us that extra clarity so there wasn't noise in the data. Now, if you're listening and you got an old 602 and you're like, man, it's going to vary 5 horsepower per run, well, that's what you got. You know, you're not going to be able to get any tighter than that. So the video there is you're not going to try to. You wouldn't try to gain 2s and 3s. You know, you're going to see if it moves the needle and understand that 5s are going to be what you're looking at. If that's all you got, then that's what you got. If you got a dyno that can give you 1s, then look for 1. But understand the noise. That's what I'm trying to say, is that you got to understand that and factor that into what your expectations are, because that's going to be really helpful in interpreting the data and knowing what's there, what's noise and what's not. And that really kind of brings it back to a quote, and I'm not sure that really Scooter's the guy that said this, but he's the one that I heard it from, and I've heard him say it over and over again, and he put his money where his mouth is in regards to this. You can't change what you can't measure. That's really, really key. You know, when Billy Godbold is the one that told me the story initially, is that, you know, when Billy wanted to buy a CNC cam grinder to do the cup cams and pro stock stuff, Scooter said, well, what are you going to measure it with? And he's like, well, you know, cam doctor. He's like, no, you know, if you have a machine that's capable of grinding something within millionths of an inch, you can't measure it, you don't know what you have. You got to be able to measure something. So it made more sense for them to buy an AdCol before they bought a CNC cam grinder, because the AdCol could measure down to 1/10 of a micron and tell them what's going on. And it's like, oh, okay. Well, you know, if you can measure 1/10 of a micron, now we can start getting better with the Burkos and the Landises and all that before we get into everything else. So that's again, the key thing is you back to expectation, what you can expect and what not, but always let this be your guiding principle. You got to be able to measure it before you can change it, and having good, reliable, consistent, precise, accurate measurements are the key to having trustworthy data that lets you make good decisions. You know, the tools that I use the most, and now I'm going to kind of transition a little bit into my oil experience, is, you know, one, again, can't thank the guys at Shavers enough for the help they provide us with being able to utilize the Black Widow dyno they have out there, which is a fantastic tool, very repeatable, very easy. You know, again, it's automated. That way you take out, you know, the human factor. And of all of us that have ever run a manual dyno knows that, yeah, the driver has an impact, you know, on the dyno. That one being completely automated, you know, both servo valves. It's got 2 servos on it, both an inlet and an outlet that are automated control, as well as the throttle. That it's got, for a water brake, exceptionally good repeatability, which is key for our testing. And then using the AdCol to be able to pre-measure cams, and then be able to post-measure a cam to see, well, what was the cam wear? Well, using an AdCol, you can know that and know it, you know, to a very, very high resolution of knowing, okay, we know what it did. And then also using the Zeiss profilometer gives you that third dimension, not just the 360-degree view of what the cam lobe looks like, but going across it, left to right, you can get a contact patch, if you will, across the top of the cam. And then also, we're also using used oil analysis, which to me is a great tool. It's one of the most underutilized tools in the industry. If you're not well, you're feeling sick, you go to the doctor, what are they going to do? They're going to take your blood. Why? Because it gives them a chance to look inside you and see what's going on inside you without cutting you open. Used oil analysis lets you look inside your equipment without pulling it apart. It's a great, great tool. Tells you the health of the engine, as well as the health of the oil itself. So that's, again, a great tool that can be utilized that we use a lot. Plus, the nice thing here is, if you see it, you're not relying on only one point of data. What we're doing here is going across the whole board, and you're able to utilize, horsepower data, torque data, temperature data, ADCO cam wear data, the Zeiss contact patch wear data, used oil analysis data. You're layering all that data together, which helps you paint a more clear picture that helps you move forward in your decision making. And that's the real key of utilizing multiple tools, multiple points of reference. That way you create a more three-dimensional picture, if you will, of what's going on. Just kind of give you a quick example, a real-world example. So what you're looking at here are the Zeiss profilometer results from two different cams, both the exact same cam grind, measuring left to right across max lift. So if you can visualize taking, the cam, holding it, say in this position, this is lobe 1, so on a small block Chevrolet, that is exhaust number 1. And so you rotate the cam till it hits max lift. You can use a profilometer to go left to right, and that measures the contact patch, the wear scar, if you will, across max lift. And what you're seeing here is an example of using what we call ZDP-A and ZDP-B. You may or may not be aware that when we talk about zinc, you're actually talking about zinc dialkyl thiophosphate. That's the chemical compound. But there's more than one type of zinc dialkyl thiophosphate. There's more than one supplier of zinc dialkyl thiophosphate. And as you can see right here, there is a variance in how they work. So you can have the same amount of ZDDP, 2,400 parts per million, but the results can vary when you look at the amount of the wear patch. And so that's again, a tool that allows you to see variances, and something you wouldn't normally be able to see is using the profilometer to look at that small area. But then we can overlay that same data with the ADCO measurements. So the wear rate in microns with 6 microns per hour with ZDP-B, and then 8 microns per hour with ZDP-A, right? I didn't change my theme there, so that's my bad. But those are the two different ZDPs, or the two different oil cams, and you can see the difference there. And then you can go a step further and look at the oil analysis report. So ZDP-A produced 10 parts per million of iron wear metals, 9 parts per million of aluminum wear metals, versus ZDP-B that produced 5 parts per million iron and 4 parts per million aluminum. So the whole point is you've got 3 different tests. All 3 have directionally the same results, right? ZDP-A versus ZDP-B, you can visibly see a difference in the smaller wear scar with ZDP-B. Same thing when you go look at the ADCO cam measurement, and then the used oil analysis measurement back that up. Again, that layering effect of building one off the other, that way you've got real confidence that, guess what? ZDP-B is better than ZDP-A, right? The goal wasn't to get the lowest ppm. The goal was to understand which one should I use. You tested both. You went through the whole process. Now we can say, okay, my decision making is pretty obvious. I want to choose ZDP-B, not ZDP-A, because I get better wear protection from ZDP-B. That's the goal. That's the point. That's kind of a little analogy or a little example from real life, from my past experience in the last couple of years, of how you make decisions and utilize all of this and action off that data. Which kind of comes back to, again, be aware of the limitations. Again, I go back to what Scooter said, and I can't emphasize it enough. You can't change, you can't measure. You got to measure, measure, measure. It's so important to have that multiple points of data to rely on it. And it kind of goes to the point of, people may not know it, but you need to go buy a car, and it's got that little EPA sticker on the side of the car that says it gets 28 miles per gallon city and 34 miles per gallon highway. there's drivers whose their job is to drive the EPA test procedure. Just to get those numbers, city and highway, there's a designated procedure that the driver must drive. So they take cars that are already produced, they drive them, and they drive them on a chassis dyno in a very specific manner. Those drivers, that's what they get paid to do. In fact, some companies know which drivers are better than others at hitting the procedure, because if you're not accurately running the right course, you're not going to get the right results. So again, it's a kind of a sidebar example of being aware of the other influences to know what's going on. I talked about used oil analysis and how beneficial it is in terms of being able to see inside your engine. One limitation of used oil analysis is that it can only see particles that are less than 10 microns. So if you can see a bunch of stuff in the oil, it's already so bad that the used oil analysis can't see those parts. Not to say that if you can see it, then you shouldn't have the samples done, but just be aware of the limitations that it can only, your eye can see particles that are about 40 microns and larger. It can't see those particles that you can see with your eye. The benefit of used oil analysis, it sees the stuff you can't see with your eye. And that's the benefit there. Other things we came across, fuel formulations change throughout the year. So if you have the same engine that you put back up on the dyno here and there, or yonder, or this or that, especially with pump fuels, the ethanol content changes seasonally. There tends to be more ethanol in the winter, less ethanol in the summer. So the amount of ethanol is going to change the amount of oxygen in the fuel, which is going to change the air-fuel ratio. Also changes how well the fuel atomizes, which will affect air-fuel ratio as well, in terms of what it actually can burn. So you got to watch out for the fuels. Really pay attention to the seasonality of the fuel, because I've seen it on the dyno from month to month with the same test engine on the dyno. The peak torque values will change, and it's like, wait, hang on, what happened? Well, that changed because of the amount of ethanol in the fuel. All right, the fuel change that had that influence, which again kind of leads you to say, look at all the environment. Pay attention in your specification, in your area, what things might be having an environmental impact. The temperature of the measuring equipment has a big impact, seasonally on what things are. You get the same measurement in a cold room is going to be different than a hot room. So keep those things in mind. Again, measure. You've got to pre-measure parts so that you can post-measure parts. If you don't have a pre-measurement and you post-measure it, doesn't make it a thing. You got to know what it was before, and you got to know what it is after, and you got to be precise and have a methodology approach that you do. We're going to put that part in this room at 72 degrees Fahrenheit. We're going to keep it there for 24 hours, and then we're going to measure the part, and we're not going to take a part right out of the dyno and measure it. We're going to make sure that there's the parts are being measured at the same temperature and the same way on the same equipment. You follow the procedures to eliminate variables that can throw you off. That's important. Other thing, limitations. And I kind of throw this out there, and being you guys who are friends with me on Facebook, you probably saw me post this the other day. But just because you get an oil analysis report and it says there's zinc in the oil, now, let's say it might say there's 1,200 parts per million of zinc. That's the element zinc, right? The atom zinc. Does anybody think that the zinc in that Tropicana orange juice is anywhere near the same type of zinc that's in motor oil? Obviously it's not. The zinc in your multivitamin is closer to what the zinc in that orange juice is, which is completely not the same type of zinc that's in motor oil, right? Because the zinc that's in motor oil, that atom zinc, is part of a larger molecule, the zinc dialkylthiophosphate. And so what happens is when you see a oil analysis report that says there's 2,200 parts per million of zinc in the oil, that's not telling you the chemical structure of that zinc. Just like the example we showed earlier of ZDP-A and ZDP-B and the big difference in the amount of wear between the two, you go back and look, the amount of zinc in the two oils is the exact same, but the molecular form of the zinc, the chemical structure, was different between A and B, and that gave a different result. So beware of these reports that make claims about things based on just parts per million or this or that. You really can't interpret what it is because it's not telling you the chemical form that it's taking on to get there. And that's as important as anything else. And, other little key details to keep in mind, as you guys can see here, there's a pretty good delta between the 2 horsepower numbers and torque numbers there. That's on the exact same engine. As you can tell, that's only 2 pulls different. The difference between the first pull, which was the 67, and the last pull, which was 69, is we drained out a half a quart of oil. With a small block Chevrolet, with a stroker crankshaft and a stock oil pan, if you put 7 quarts of oil in the 7-quart oil pan, right, you get the bottom number, right? So the bottom line down there, 69, is 7 quarts of oil in a 7-quart oil pan. The number on top, 67, is 6.5 quarts of oil in a 7-quart oil pan. And it just goes to show that you got to keep up with little details like how much oil's in the engine. And it's really easy to say, well, I put in 6 quarts of oil. Well, if you put in 6 quarts of oil and you're doing, let's say, do oil testing, you drain the oil out, did you get all 6 quarts of oil out? Probably not. So you have to watch the oil level and not just keep putting in oil, because what will happen is if you put in 6 quarts of oil and you drain out 6, and then you put another 6 in, you're not going to have 6 quarts of oil in the engine. You're probably going to have 6.25. If you do that over and over and over again, pretty soon you're going to be at 6.5, maybe even 7 quarts of oil, and now your numbers are going to be skewed because of not having the proper oil level. And we probably all have the same experience. You can go pour the oil up to a certain point on the dipstick, walk away for 10 minutes and come back, and then check the dipstick again. It's going to be even higher because it takes time for the oil to make its way from the valve cover down to the valley, down to the oil pan. And the heavier the oil that you use, the colder the environment is, the longer it's going to time to take it. So you have to be very precise in the amount of oil in the engine. In fact, when API does fuel economy testing, the entire engine test stand is on scales, and they weigh in the amount of oil. Let that sink in for a second. Because oil volume can change with temperature, but the amount of oil can't change with weight. Your weight doesn't change with temperature. Volume can change with temperature, but weight does not change with temperature. So they weigh in the amount of oil to be used. That way there's no variance, no influence on the outcome of the test by the volume of oil. So something to kind of keep in mind to make sure that you're staying on top of when you're doing testing, to maintain that same level of oil, same volume of oil in the engine at all times. That way your results are reliable. And part of that process is you think about them weighing it in, how crazy that sounds, but you got to remember when they're doing fuel economy testing, they're not rebuilding the engine between each oil. So you're having this same engine and it will maybe run in one day a couple of different oils. Well, how they go about doing that is they actually have a baseline oil they run, and then they have a flush oil. So they run the baseline oil, get a number, they drain it out, they put in a flush oil, run the engine for a specified amount of time, and they drain the flush oil out. Then they're going to put in the test oil, and they run the engine for a short amount of time on the test oil, and then they drain that oil out. Then they put a fresh fill of that same test oil in, and then they run their test. So the first run, the baseline, is a measured run, and the last run is a measured run, and you have 2 flushes in between to make sure there's no carryover effect. That's called a double flush. And if you're not doing a double flush when you're horsepower testing oil, you're not actually horsepower testing oil. You're just wasting gasoline and your time. And that sounds kind of arrogant, but I just want to really hammer that home, that unless you're doing that procedure, you're really not testing horsepower on the oil. We've actually seen it when the Gibbs guys started the motocross team. They hired these guys in, they started getting ready to go, and they went and tested a bunch of different oils on the motorcycle engine dyno, and they came back to us and said, well, here's the result. None of these things really seem to do anything that great. We looked at them and said, how'd you run your procedure? Oh, I said, we started with this oil, and we ran it, and we drained it out and put it in the next one, and kept on doing the same thing. So, well, you can't do that. And I'm like, what do you mean? I explained to him the double flush procedure you're looking at in the screen right here, and said, yeah, by the way, you gotta make sure you check the oil level so that, that you're only putting in the amount you need. And they went back and ran that same test again with the same oils, but changed the procedure, used the double flush, used the level measurement to dictate the volume of oil put into the engine each time, and the results were completely different than they had the first time. And so that was, again, a good example of an eye-opening moment to them of, oh, okay, there's a lot more to this than we realized that can guide you along the right way. And then, another example is, and if you got time, especially if you have access to SAE papers, I looked at the SAE paper number up there. A good story is this. So back before Gibbs even did business with Lubrizol, Lubrizol and RCR and Unocal were working together because at one point in time, Lubrizol's got their engines and they're doing all their testing using passenger car engines. And they came up with this whiz-bang triple detergent formula that had magnesium, sodium, and calcium detergents all in the same oil. And all the industry tests for passenger cars, the stuff is phenomenal. So they go over to Unocal and say, here's our best new package. You need to put this in the 76 race oil. So they do that. They send some down to RCR. RCR puts an engine and blows the engine up. Of course, RCR is like, well, that doesn't make any sense. I thought it was supposed to be the best oil. And then Lubrizol scratching their head trying to figure it out. Well, the three of them worked together, developed a testing procedure to do race simulations and figure out what was the best additive chemistry for the NASCAR engine. Because that NASCAR engine was completely different than the passenger car engines. Not only was it flat tappet, it was also much higher revving. The fuel was different. All these things factored in. And they came to find out then that best additive package for a street car was not the best additive package for a race engine. And while that really went against the conventional wisdom at Lubrizol in terms of what their internal testing said, because they had worked together and developed a rigorous procedure, they all felt like had good measurement and was quality, and it was a both accurate and precise test method, and they had followed the method. They didn't deviate, of course. They had the confidence at that point to follow that data, even though it was leading them in a direction that was against everything they had ever learned before. And in the end, they ended up making better products. And by the time that we got a hold of them at Gibbs, we were really able to benefit from those results. And we took that learning of, okay, we got to have a goal in mind. When Mark Cronquist and those guys who started working with Lubrizol, was all about, we got cam sailing, we need to fix it. Well, then we learned from Lubrizol, from their experience, of how to devise a proper program, work through it, and over time we just continued to develop and build, and that led to some great success. I can tell you for a fact that prior to JGR working with Lubrizol and taking on this testing mentality where you committed to testing, you committed to doing things in a certain way, that Joe Gibbs Racing had only won 16 races and 0 championships in the 8 years prior to working with Lubrizol. In the 8 years following that, Joe Gibbs Racing won 84 races and 5 championships. That is not a statistical anomaly. That happened only because of the commitment that Gibbs made to that program and to follow the rigorous testing and to let it take you wherever it took you. And as a result, we were able to benefit from it greatly. It was, so far in my career, probably one of the most rewarding times and things I've ever been involved in was, Tony Stewart lifting that trophy in 2005 at Homestead was quite the year, quite an amazing thing to be a part of, and very proud of that, as well as other things. But, that was a really, really inspiring year to see what it all transpired and what happened through that season and how you got to that point. So with that, I'm happy to take any questions anybody might have. I know we're getting here toward the end of the hour and people need to get back to work. So fire away, and I'll be happy to answer any questions if you have them.
Sure. I've got one for you, Lake. Doug has called in, and he's got a couple questions all wrapped up into one here. He's got, can you comment on a drag race motor, stock limiter racing small block Chevy 350 with 441 heads? The trend seems to be tighter bearing clearances, low viscosity oil to improve the horsepower, and lower lapse times on drag strip. What does this do to wear of the engine parts? How low of oil pressure can we go on a drag race small block? Or what makes the most horsepower, low oil pressure versus low viscosity oil and tight clearances?
Well, thanks for the question, Doug. And really, you're kind of hitting on all of them. And it is the package. And that's the key thing to keep in mind, that when you go to tighter bearing clearances, you need to go to lower viscosity oil. And that by itself tends to bring down oil pressure. You got to remember that oil pressure in the end is just a result of oil flow. It's resistance to flow in the engine is what reads the gauge pressure in the engine. So you can have flow through the engine with very low pressure. I know from our early days in dealing with pro stock, Jason Lyon used to work at Gibbs, and so we had a great relationship with him when he first got into pro stock drag racing. And you go up there and the engine was idle at nothing. I mean, I remember Daytona Talladega motors. The engines would idle bouncing on 0 oil pressure before you go out to qualify. Then you would actually run the race at 40 pounds oil pressure wide open. Now, of course, those were restricted motors, so you didn't have the cylinder pressure you have. And that's one thing to keep in mind, is that as you go up in cylinder pressure, you do have force through the engine trying to, kind of push the oil out of the way. So at some cases you kind of need to have enough pressure to make sure you're forcing the oil out to the rod, that it feeds itself out there, to overcome that, the forces that are acting in the mains, and to make sure you get oil to the top of the engine to lubricate things properly. So the point being is, you definitely want to go with tighter bearing clearances. Definitely, a thou per journal inch, even slightly tighter, even maybe down to 0.8 per inch in some applications, with a little bit lower viscosity oil. One thing is you'll be limited to in the end is how strong your crankshaft is. The more your crank flexes, then that becomes a limit on how tight you can go and how thin you can go. And one thing about oil pumps is you might want to look at narrowing the pump and blueprinting the pump in order to make the pump more efficient. The smaller the pressure section, the less drag there's going to be. And by blueprinting the pump, you can get a smaller, narrower pressure section that's still efficient and can deliver what you need to do to keep the engine alive.
All right, Lake. We had a question come in from Thomas also. and he is asking, what would be a flush oil?
Okay, so most people don't probably want to go buy the ASTM, which is the testing society prescribed flush oil, because it's really expensive, and I'm not sure it really does that thing great for you. The couple options are out there. One, break-in oil. A break-in oil is basically non-detergent. It's non-friction modified. It's a mineral oil, so it's neutral. At Gibbs, when we were doing all the testing, we always used the Gibbs, the BR break-in oil as the flush oil. I know you can also, if you don't have that handily available, you can also use an oil like Rotella or something like that. The only downside to using the diesel oil is they're really high detergent oils, so they tend to the carryover effect of that additive package last in the engine longer. So that's the only downside. You just kind of watch that.
All right, I've got another one here for you, Lake. The questions come in, and it goes, are rooms used for measurement testing, including the equipment kept at a particular temperature? Does everyone agree on that particular temperature?
Yes, in fact, back to ASTM, which is the testing society, they actually specify 25 degrees Celsius as room temperature, standard temperature pressure, as what the room should be held at. And I know, for example, we do a lot of testing with the guys at Comp Cams, that their quality control room is always 72 degrees. So in the winter, the middle of the summer, it's 72 degrees. It's climate controlled always. So and what our procedure is that all the tools, all the equipment stay in that room always. And then anything that be tested comes into that room, and we let it sit overnight so that it has a chance to cool off to room temperature before we measure it.
All right, and we had a question here from Wayne, and Wayne is asking, on a typical drag race motor, bracket racing, how much difference should you see between water temp and oil temp?
A lot of that depends upon if it's a wet sump or a dry sump system. Our experience has been that it takes about 8 to 9 minutes. If you're running an engine at, say, 3,000 RPM with about a, say, 10% load on the dyno, for the oil temperature to actually catch up to the water temperature. So the water temperature is going to go up much faster. And so a lot of times in a typical drag race engine, while your water temperature may be at, say, 180 degrees when you cross the finish line, your oil temperature is probably only going to be about 140, 150, depending upon any kind of warming up you're doing prior. You think about it, say, a pro stock engine where the water's dead cold and they tow the car up to the line, and the water's chilled and everything, the oil temperature never gets over 100 degrees in the engine, even at the end of a pass in the middle of the summer. A typical super stock car that may drive up into the lane is probably going to end up running somewhere around 150 or so. So I'm going to say typically you're about 40 degrees roughly behind the water temperature with the oil temperature in a drag race environment. And of course, that's the opposite for circle track. If an engine's running, 220 on water in a circle track application, it's probably running at least 260, 280 on oil, sometimes even worse, depending upon the application.
All right, so we have time for one more last question. I know we've got other questions sitting there, and what we'll do is we'll pass those along to Lake, and we'll get back to everybody, make sure you get all your questions answered. But Lake, Chris has a question. What's the advantage of using a flush oil versus flushing with the next test oil?
So the idea of having a flush oil is that you're capturing all of the remains of the previous oil, which typically is going to have, if it's a race oil, for example, it's going to have all the friction modifiers, the synthetic base oils, all that kind of stuff in there. And you want it out because If you just skip to the next oil, sometimes you can have, say, for example, the two different types of ZDP, right? There's ZDP, but there's more than one type. Well, not all chemicals get along very well, especially synthetics are more particular, if you will, in terms of how they interact with each other. So by using a mineral-based flush oil, you limit the amount of contact between the two oils. I know from our early testing at Gibbs, there were some synthetic oils you could not run back-to-back in the same engine with other synthetics. They would always have an additive clash. If you ran a flush oil in between, you could run the two back-to-back, but they had to be separated by something that was non-synthetic, non-friction modified, and that's the big advantage of running a true flush oil, even say not even running a diesel oil, because now today the diesel oils are completely different. The CK4, it's better to run a flush oil like a break-in oil that can make sure that those two synthetics don't ever touch each other.
All right, super. So for all those that are listening, if you got any more questions, like I say, we'll make sure to get those onto Lake to get those answered, and we'll get back to you, and we'll get those questions answered for you. We really appreciate this, Lake. You've done a great job, and this is kind of taking testing to a whole new level for sure.
Well, I appreciate the opportunity. Thanks for everybody for hanging in and listening for so long. It means a lot to me. I'm sorry for rambling. You know, it's the first time I've done one of these specifically on testing, so I appreciate everybody bearing with a newbie on that one.
No, this is information you don't normally get to play with or see, so we really appreciate it. Thank you very much. And for those of you that are listening, that are going to be listening to the recording, same thing. If you got any questions while you're watching the recorded version, by all means, if you get back to either Amanda or myself, and we'll show our email contacts here on the next slide, we'd be more than happy to get those over to Lake so that you can get those questions answered, and we'll get back to you with those for sure. And just, one quick note here before we take off, AERA as well as Lake will be at the PRI show coming up. So keep in mind that you can come visit us. If you got any questions for Lake, I know he'd be more than happy to answer those for you too while he's at the PRI show. We'll be at booth number 5514. Also catch us at the ATEC conference. We'll be there December 5th and 6th, so that's the Tuesday and the Wednesday. You'll also catch us at the Student Career Day, which is on Friday morning on that December 8th. So lots of opportunity to come see us. We've got some new programs for 2018 we'd like to show you as well. Again, Lake will be at that PRI show, and he can help you out with any questions you may have. I'm going to go over to Amanda now for half a sec. She's just going to kind of go through with you how to do a survey and how to get a hold of us. And again, Lake, thank you very much. We really appreciate your time.
Happy to do it. Thanks for the opportunity.
All right, everybody. This is standard protocol, as many of you know that are on these. You will get a follow-up email from us tomorrow with a link to today's recording. You can forward that to whoever you want, watch it at your convenience. Also, when you close out of today's webinar, you are going to get prompted to take a survey. Please take a moment and do so. It just helps us know how we're doing, if there's any other questions you have, anything you'd like to see from us down the road. So we really appreciate you taking a moment to fill that out and get us that information. And lastly, you will see we have our contact information listed there for AERA. That 815-526-7600 number will get you to the main line where you can reach any of us. And you'll see our email addresses are also listed there. You can also just reply to any emails you get regarding webinars, and they'll come straight to me, and I can pass along your questions accordingly. So thanks again, Lake, and to everybody who was listening, we appreciate your time, and have a great day.